Hi everyone. Today is a special day for this little device right here, and I wanted to save this for this day to be exactly on the day. Well, this might be the 2nd now, the 2nd of August that you're receiving it, but this here was created, this little creation that I put together here was created in 2003, August the 1st. This little lamp that you see here has been glowing 24 hours a day, 7 days a week, non-stop since August the 1st, 2003, and it still works fantastic. No problems with it whatsoever. What is it? Well, I got sick and tired of buying night lights. So night lights always burn out. There's been so many different types of night lights, and I have night lights all over the house, right? You know, through the years we've had different pets and stuff. And I've got these all throughout the house here right now. And so I don't trip over Charlie at night. Charlie's our dog. And, you know, just things like that. And I like an amount of light that's comfortable to see, but nothing that's too bright, nothing that's, you know, when you're trying to sleep, it's going to bother you. And this turned out to be the perfect little lamp, and it has a neat little feature of it too. So inside this lamp here, which I'll show you in just a minute, this is one of the many circuits inside my entire book here, which I will share many of these with you. This piece of paper here just for ease of looking. Well, this is also attachment below the video, by the way. You can just go below the video and there's a PDF down there, and you can download PDF if you want to take a look at this. Anyways, so these little lamps here I created because I was, you know, tired of buying them. They're always failing, right? So, you know, why don't I just try to create something that's just not going to fail? And I succeeded. It worked very, very well. And there really is no magic to this. You know, it's a very simple circuit. In fact, it's so simple it'll surprise you, and it's just dependable. And now, like, this was 2003 when I put these lamps together, right? Blue LED technology was just coming out, right? So, you know, it was the blue LEDs were kind of like, ooh, the big rage. So I put the brand. I picked up a bunch of blue LEDs. I got a blue LED and a green LED in this thing, and what's really interesting about this little acrylic loop here is blue shines up one side, green shines up the other side. So if you look at this thing up against the wall, it looks blue and green. But if you look up the wall, the color is white. It makes a very nice white color on the wall. So it illuminates the room. I would call it a comfortable white color. So, and there's no red involved either, right? It's just blue and green. So that worked out very nice. This acrylic rod and the two lights, or the two LEDs in there, worked out very, very well. So I wanted to share this with you today. And, you know, you don't have to build anything like this. You could, you know, just experiment. You can also experiment with different colors of LEDs. There's a trick to making LEDs last, and I'm going to share that with you today as well, so you can get the maximum amount of life out of the LEDs. Now, it's not real, you know, it's not rocket science at all. It's a couple of things, but the thing is the blue LED technology has increased so well. You know, if they were run the way that this thing is run, I can see the thing probably lasting indefinitely if it's put together properly, you know, as long as they're not, you know, reject blue and green LEDs, right? So anyways, how this works here, I have a bunch of news today that is also very, very positive, and that gets me back on the track for releasing many of my inventions. I'm going to talk about that here as well. And I'm going to share a circuit with you that will also save the meter in your tube tester. I had a really bad thing happen to that B&K 707 after the video was done, and I will share it with you. And it took me a long time to fix it. So I would call it a disaster because of a tube I plugged in, believe it or not. So I'll share that with you in this video as well. So lots of interesting stuff here today. So exciting stuff. Anyways, this is below the video. You can download this. You'll notice a disclaimer on the bottom here, and if you are a patron and you find any of these documents public, it says right here, definitely let me know, because I will go after whoever it is. I've gone after people who have taken my circuit boards and tried to go into business with them, and I've come to settlement. All right, so this is for you to build, you know, and this is, when it says it's not public, I mean that. It's supposed to stay here. And everybody that takes something like this, or any of the things that I release public, are jeopardizing what you're getting here. All right, so all those people that are cheating and taking this stuff and trying to do this for personal gain are really screwing you over. And they're screwing myself over as well. So if you ever find any of this stuff that's public, definitely let me know. and I'll be hot on the trail like I am with many of the other people. Now you'll find some stuff that I have posted public. They've asked me for my consent, and I've given that to them. All right, so there's some things have been publicly released by me, and then some people take it and then put them on their website. Like, for example, the Super Probe, okay? The Super Probe was released publicly. It's just I have my own personal plans here on Patreon, okay? So, like, the personal plans of mine, like the circuit board design and everything, yeah, that's supposed to be here, but the actual, the schematic and layout and how the thing works and everything, that was all released public, and that's absolutely fine. People have taken that schematic and they've redrawn it, and they've tried to make through-hole stuff and things like that, and I've allowed that. All right, they've asked for permission, but the stuff that is not supposed to leave this site is the intellectual property and things like that. I'm right on top of. All right, so if you do find any of this stuff public, there's been a couple of online courses that have taken this, and they're using this in their own online courses. Not this particular project here, but other of my, and I have to go after the actual school that's using my stuff in their actual school. So things like that. Anyway, so enough of that. Please let me know, because again, this is for all of you to enjoy, and this is the reason that you're here. You're getting the benefits of being here, and of course the teaching and everything like that, and of course you're getting my releases. When people take this stuff public, it just wrecks it for everyone. Anyways, so this is the plans for this thing. So we have two LEDs right here, a blue and a green LED. You can see how they're just basically in series. So we have a diode, 1N4007 right here from this pin here, and it just goes through a 15K 5-watt resistor out this pin right here, and that's all it is. So these LEDs, they're high brightness LEDs. That's very important. All right, these are both very high brightness clear LEDs, and they go and go and go. Now, the thing to make these things last long, and I've experimented with this, and it is very important to remember this, is that you want to solder the connections as far away from the LED as possible. Don't cut any leads ever close to the actual LED and solder them right at the LED. I found that twisting these also could create an issue. Again, you want to keep them about as long as possible inside the device. So this is one of my very, very early ones that I experimented with, and you can see I cut them close. Now it still works and everything, but it's still not a good idea for the actual LEDs, because that will, if you overheat them, a little bit too much heat too close to the LED, especially high brightness ones, is kind of an issue for them, right? So this resistor here, if you dead short it, by the way, I wouldn't say dead short it, but you put the AC line right across this resistor here. So you have 120 volts right across this resistor. So worst case scenario, the diode shorts, the LED shorts, and the LED shorts. So basically you have just a circuit. This resistor here will get comfortably warm. That's all it gets. So the boxes I've used are flame retardant boxes and everything, so lots of thought went into this. But this particular resistor here, resistors usually will not short ever. All right, they really don't. There's really fine wire in here, and of course, when they're running, it's so low. Like, this thing is probably dealing with about a watt or so, something like that. Anyways, without doing the math quickly, about a watt, maybe just a touch over a watt at 125. Worst case scenario, I would think. At any rate, it just gets comfortably warm. So, and when I say that, I could hold my fingers on this resistor all day long, and it would be comfortable on my fingers. So that's what we're dealing with. If you were to not dead short, I shouldn't say, but connect the AC line right across it. So it's quite a huge safety margin there. Now, if you were to build this, of course, you're doing so at your own risk. Read what it says down here, and if you're uncomfortable with working with the AC line or anything like that, don't build this. And all of that kind of stuff. But as I say, all of these have been together for 20 years now, 20 years in a day, I guess, probably by the time you're seeing this. So no issues whatsoever. And this little box here just gets, because the resistors inside and it's screwed together, right, just barely warm. You can barely feel it. But this here will pull, okay, in this configuration here, we'll pull about 4.2 milliamps all day long. And then, of course, if everything was to short it, aside from the resistor, right, again, resistors 99.9% of the time never short, right? Especially this, right? So if this was to short, and if this was to short, and if this was to short, you're going to draw about 8 milliamps through here. Something like that, about 8 milliamps while you don't cross this. So, do the math if you like. I think it works out about 1 watt, maybe just a touch over, something like that. Anyways, just off the top of my head. It's been a long time, as you see, it's not written down here, right? So these are the little devices that I put together, and they look really neat, and I figured I would share this with you. Now, you don't have to put it in this box. It can be built so many different ways. You can put these in a different type of box or whatever, and if you want to run an isolation transformer, you want to do whatever you want, that's up to you, right? Again, this is how I built these, and this has worked for me. So I'll plug this in here. Now, there's a lot of light on the bench, all right? And this will look kind of purple here, but actually it's blue. The camera does that. You'll notice all cameras kind of do that to blues, especially blue LEDs. So what I'll do is I'll just turn the lights off here, and maybe I'll get a filter on the camera so you can get a better idea of it here. Give me a sec. So there you go, and that's starting to turn blue. It's about that's the blue color right there that you would be normally seeing. So this is how the LED looks, and this is how the green and the blue both look. And as you can see, they're both full bright, no problems, both the blue and the green. They held out very nicely. So give me a sec here, I'll just turn this back up. I think I'm at the end. I think I am, yes. So that's how it works. Again, you plug it in, you look at this right up against the wall, and you see the green and the blue, but you look up the wall just a little bit, and it's like white light. It's very interesting. It's almost like it looks like this right here. It's got this kind of a whitish kind of look to it. It's a really, really neat little lamp. 20 years, 24 hours a day, 7 days a week. The only time this thing has ever been off is in a power outage, and that's it. That's absolutely it. So, works very, very well. So I'm very happy with this. I'll turn the light back on here. I'm very happy with these things, and I figured I would share that with you today. So if you have an idea for a night light that you would like to put together, the circuit itself is solid. It doesn't need to be in this particular configuration, and you can try different color LEDs as well. It's quite current limited with a 15K 5-watt resistor, right? So you can fool around with different colors and all that kind of stuff. Again, the trick to making these LEDs last long is very low current. Run them at extremely low current levels because they're high brightness. They glow brightly at extremely low currents, and solder as far away from the actual LED as you can, and use a very low heat so that they just solder together, and that's it. If you want, you can actually heat sink the leads of the LEDs, and these things will go for a very, very long time. Again, the LED technology has come a long ways since when I first bought these things. So, blue LEDs, they would burn out very quickly. My old HP that I got way, way, way back when had a little blue LED in the power light, and it was gone within a few years, right? So they're all, all the blue LED technology, early blue LED technology was not really perfected. But by now, you can get blue LEDs in all sorts of different shapes and sizes, and I guess you could say color variants of blue and all that kind of stuff. So kind of fun to experiment with. So there you have it, attachment below. And I hope you enjoy this. I'm pretty proud of this little lamp. Yeah, they're great. In fact, if this thing is still glowing in another 20 years, I'll be even happier. So will I be around here in 20 years? Well, who knows, right? If I am, we'll have a 20-year or a 40-year anniversary for this thing. How's that? So there we go. Hope you enjoy. On to the next bit of news. I have some really great news. The electronics manufacturers that have had no stock on the components that I need to make my little creations magically have stock now. And I'm not talking about 1 or 2 pieces. I'm talking about a lot of the pieces. That to me is very, very strange. And I mean, like, nobody had this stuff a month ago. Nobody had these things. And now all of a sudden, multiple manufacturers have stock again. So who knows what's going on with that. But at any rate, that allows me to get back into my circuitry again and designing the things that I want to release, my little inventions and things like that I want to release to you, which is makes me very, very happy. I just stumbled across this recently, and I myself have placed a very large order again, so I can get back into everything. So that is some really, really great news. For a while there, I was actually getting very frustrated with getting components because it seemed like these components should not be out of stock, or there should not be a shortage on these components. They're as common as dirt, some of them, and nobody had them anywhere to be found. And if you wanted to find that component in, say, a different package, you're looking at, you know, maybe 500 to 1,000% markup for one piece. Forget that. So, you know, that's, you know, when I see that kind of stuff, that's just highway robbery, right? So at any rate, the normal components are back in stock and they can be found at relatively, you know, really good prices. So I've placed an order, and of course when I release the next project, you will get a list, and that'll allow you to get the components. I don't want to design anything and release anything if you can't get the parts. When I first started Patreon, I wasn't so worried about that because some of the projects were pretty generic. You know, the parts were pretty easy to find, whether it's a, you know, 2N3904 or you know, or an MMBT 3904 to some other different, you know, like a BC numbered part or something like that, like the 2N3904, 3906, or BC 807 or 817 kind of complement idea. And it's pretty common stuff. You can just, you know, substitute with so many different parts. But a lot of the stuff that I've been creating lately requires some pretty specific parts, like the front end of the capacitor tester, and you know, the mixer FET in the signal injection probe, right? You know, things like that. There's all sorts of different things. So now a lot of these components have become available, and that makes me very, very happy. So that allows me to proceed back on and create a lot of the things that I wanted to release. So that makes me very, very happy, and it allows me to, you know, get back to work with that again. That's very, very good news. So I hope you're as happy about that as I am, because you'll be getting some pretty neat circuits here in the very near future. So I got pretty frustrated with the Ultra Probe, let me tell you that. You know, changing my entire design around, which I started working on to fit components that I was not happy with because everything was unavailable. And then all of a sudden, now all these common as dirt parts are now, well, not as common as dirt now, but they're, you know, they're back available again. So I'll go into there and re-engineer it. And of course, I've added some features as well again. So yeah, lots of really neat stuff's happening here. So that makes me very, very happy. I hope you're as excited about that as I am, because not being able to get electronic components is not a good thing. Now it seems like production is starting to ramp up again. So either some factory or something's opened up, or the really realistic shortage. You know, I don't know what it is. Lately, there's been shortages on everything, it seems, and magically those shortages disappear. They just go away. So hopefully this craziness and shall we say maybe fake shortages stop. So good news there. Now let's take a look at that tube tester, and you can use the circuit for other things as well. So you don't need to just use it as a tube tester. It's basic just meter protection, and this will give you an idea of my thought process behind this. And I'll talk a little bit about what happened to that meter in the B&K 707. I was not happy, let me tell you that. Okay, let's go take a look at that. This tube tester has been sitting on the bench ever since I did that video on YouTube about this. And you're probably asking, well, why is it still sitting here? You know, how come you haven't moved on from that point? Well, I've been using the other portion of the bench. The only reason I've left this out is because I wanted to share this modification with all of you. I figure that this is so incredibly important, whether you have this tube tester or any other type of tube tester that has this type of circuitry in it. The modification really isn't all that unknown, but there is an addition to it that may greatly save you if something happens, you know, like it happened to me here. So what went on with this? I'm pretty sure you're probably already guessing. I put a tube in here that must have had a really bad short or something in it. And that was after I had done everything on the alignment and everything. Put a tube in there, hit test 1. That needle flew over to this side of the meter so hard it bent the needle like this. It knocked paint off of the needle. That's how hard it hit. Then when I let go of test 1, it came back and touched this side. And I figured at that point, this is destroyed. It hit so hard, and it bent this so bad inside. You know, you have this whole rush of emotions when you see that, especially after you spent the amount of time on this. Like, that video took me a week to do, you know, to do this alignment and to get everything done and all recorded, right? I figured I just destroyed this relatively perfect looking meter. So I had to walk away, went and got a coffee and sat up, thought about it for a little bit, came back into the lab here, put this under a microscope. Getting this off is very easy, by the way. You just pull up on the bottom. I don't want to take it apart here again because I've got this all dedusted and everything. But you just pop this up like this and you can get right in here. So I put this under the microscope and very carefully, no kidding, worked for about 2.5 hours on that needle to get it straight again. It was that bent up, cleaned all the paint off and recolored the needle again. I'll zoom right into it, and you know, very little sign of damage there. Unless you were actually looking for it, I don't think you would see it. So what that little needle feels like, it feels like a little hollow aluminum pipe. And what they've done at the end here, just before it gets into the little red area, is they've squished the aluminum pipe flat. So it's like a blade at the end. So it's a pipe, and then you can picture them squishing it down to a flat portion. Why they've done that, it's so coarse. The meter, you know, has no real fine reading on it or anything like that, but they could have left it a pipe right up to the end, but they did that. So that being bent, of course, almost on a 90-degree angle, it was bent so incredibly bad. After you touch this and feel how soft it is, you know, a little stiffer than a piece of, you know, larger solder wire, really. Once you feel how soft it is, I'm thinking to myself, I'm moving this, it's gonna snap. Like, that's so incredibly soft. Again, like solder almost, it's just so soft. So again, 2.5 hours spending here, moving this back and bending the rest of the needle straight and recoloring it, wiping the paint off in there. And then I checked the movement after that, believe it or not. So under the scope, it looked somewhat normal, so I wasn't too concerned about this here. If this breaks, you know, you're pretty much done. You know, you're dealing with a counterbalance on the other end. So if you add any weight to this, it's just going to skew the readings, right? So in order to make this read correctly, everything has to be perfect. So lots of time put into that. So I figure I have to share this with all of you, because I would hate to see this happen to any of you with any of your tube testers. Especially, I'm going to do a restoration on my Hickok tester. If that happened to my Hickok tester, oh man, my heart would be on the floor. So this is the protection that I've done, okay, that I've added to this. And you may want to consider doing this too. All it is 2 diodes. The forward and the leakage does not affect the meter, the movement at all. Okay, it doesn't affect the calibration of the unit, I should say. So I experimented. I had 2 test leads running out of this, and I plugged a good known tube in, that 6K, what was it, 6K6 I put in there, and I upped the sensitivity readings a bit just to skew the reading so I could put the meter on an actual line, like the 120 line. Put the needle right on the 120 line, and then what I did is I attached the diodes in to see if the needle would move at all, and nothing moved with these diodes. I tried some shot keys. They had a forward of about 0.145 of a volt, and they would cause the needle to drop back about 2 or 3 needles widths, something like that. And then when I removed them, it would rise up again, just that little bit. So I figured either the leakage or the forward is affecting that. So I tried these, and these are a little higher, as I say, about 0.5 of a volt. Put these across, and it didn't affect it. So I figured this is what I'm going to stick with here. So these diodes here are available at DigiKey. Now, I bought these quite some time ago. I'm hoping that these are still available. These worked very, very well. The part number is STTH3R06, and that's the DigiKey part number at the top there. And you know, they're really overrated, but you know, I'm not really looking at that. I'm just looking at the clamping ability and low leakage, and they seem to work very, very well. So you'll notice one is this way and one is this way. They're just tied together like that, so it protects the meter in both directions. And I've also added a 4700 microfarad cap across the meter. So I think this is FR series, if I remember correctly, FR series cap. It's an older cap again, so hopefully that series is still available. But this is just across here, and what this does is it just slows the rise. So normally, without this cap here, if you press the test button, it'll move up to 120 really quick, say, okay? So you press the button, quick, up to 120. With this, it takes time to charge this cap up, so the needle moves very slowly up to 120. It doesn't skew the results at all. It still goes to 120. And what I did to verify that is I tied this whole network together, and then once the needle was at 120, I removed the alligator clip from this whole network here, because this was external to the tester at that point, and there was no movement. If you apply the capacitor into the circuit while the needle is reading high, of course you're going to have to charge it, so you're going to see a dip in the needle as it'll come back up again, right? But once this is charged and it's removed, if you see no movement of the needle, you know it's not affecting it. So this has no effect on the circuit whatsoever, this combination right here. Again, make sure that the 4700 microfarad capacitor is a good quality. Now, this is a 16 volt cap because this is just what I had. This limits the voltage across this meter to about 0.45 of a volt. So you can get away with a 3.3 volt cap across this or anything like that, right? Because it's never going to exceed the forward of these diodes. So how the circuit works here is really quite simple. Now you can see how this could just destroy this meter, right? You can see, so one side of this winding goes right up to the plate of the 83. See, it runs down here into this winding. The other side of the winding goes right into the positive side of this meter, right? So this cap here is obviously to smooth any kind of jitter, right? Just smooths the action here. That's what this replaced cap here does, right? This can be left in circuit, by the way. Okay, so now the negative side of the meter goes through a 56 ohm resistor, obviously put in there to, you know, affect the calibration and possibly limit some current. It runs down here, goes through the switch, and then down to the plate of the 6BN8 tube. So what's happening here is, as this tube conducts, so as you bias the grid of the 6BN8 positive, the tube starts to conduct, all right? So it's making a path from the plate to the cathode here, right? It's all it's doing, or cathode to plate, depending on the way you want to look at it. And what it does is starts to conduct, and it starts to close. It's basically acting as almost like it's acting as a valve. It's starting to close. It's starting to, if you wanted to look at this as a valve, it's connecting the plate to the cathode. The more you bias this grid positive, the more it's trying to connect that plate to the cathode. So you can look at it as a resistor that's just dropping in value as you bias this positive, if that helps you picture it a little easier. So you're allowing electron flow in this tube as you bias this positive. At any rate, as you're doing that, what's happening is it's pulling current through this meter in the shunt, all right? So I didn't look at the meter to see if there's an actual shunt in here or whether the actual windings of the meter are just making up the resistance value of this meter. It probably does have some form of a shunt in there. So what happens is as this draws current, you're pulling current across that shunt, and then what's happening is it's basically, without the shunt in there, the thing's like a voltmeter, right? So as you draw current across this meter, it's causing the needle to deflect forward. So you can imagine what would happen if you had a short in this 6BN8 from pin 7 to maybe the cathode or to ground, just chassis ground. You would find the needle of this meter on the surface of the moon, the way that this moved with just that shorted tube. I'm telling you, that hit so incredibly hard. If you were to short this, there would be no coming back. You would find this filled with smoke, and that would be absolutely it. So, very good idea for protection on this meter or any other meter. Of course, a little bit of experimentation has to be done. The forward on these diodes is lower than a 1N4007, so I wanted to get a forward that was low enough that, you know, if I get enough drop across it, it's not going to hurt the meter, and enough forward, so and a low enough leakage that it doesn't actually affect the reading. So these turned out to be just nice for that. So there's that modification, and I hope that saves one of your meters from utter destruction like I figured this. Oh, what I should show you on this as well. I've had so many comments on this. So many people seem to think that that is a black band. The color of the band is very dark, but that is brown. This is a 390 ohm resistor, not 39 ohms like many people think it is. So that is the color brown right there, not black. I guess it's just the paint that they used that looks, I guess, relatively dark. You know, to my eyes too, it does look very dark, but it is definitely 390 ohms, just in case you were wondering about that. And this capacitor in the shot looks like it has a bulge. Another thing I will show you. That is not a bulge, that is a reflection. This thing is so full of reflections. Look at that, it's as flat can be right there. Okay, so it's just a reflection. The cap isn't bulged at all. Doesn't that look like it's bulging right there? So it's not bulged at all. So there you have it. I hope this helps you out, and I hope this saves. I figure I have to share this with you because, you know, the amount of grief I went through with this hours just fooling with this meter. If this saves you from having to do that, I've done my job. So there you go. I hope you enjoyed this video, and I'm pretty excited about the upcoming projects and the fact that these components are available again. I didn't think they were going to become available again. I thought it was done. So those particular components are available. So I don't have to redesign so much of the plans that I've already started with. That makes me very excited. Anyways, if you enjoyed this video and you appreciate the information that's provided in these videos, you can let me know by tapping the heart symbol below or just leaving me a comment in the comments section. All right, until next time, take care. Bye for now.